Hello, for this new episode of my publication at a glance, I welcome today Luca Popek. Luca is currently a PhD candidate at the University of Strasbourg, working in the Lima laboratory, and he's going to talk about his last work dealing with the introduction of an emerging motif, the SF5 group.
So thank you for the introduction and for the opportunity to present our last article about regioselective synthesis of 2SF5 adenine. As you may know, adenine core skeleton is a privileged skeleton found in natural products which display relevant bioactive activity, such as antibiotic, anti-cancer, or antioxidant. So it has several occurrences in pharmacologically active compounds with, for example, the use in the treatment of Alzheimer's disease. Our group is interested in the SF5 group, which is an emerging functionality group, which is highly polar and lipophilic and greatly stable. Because of all this property, the SF5 group is growing interest in many fields, such as material science, heterocyclic synthesis, and some drug development are in progress. However, it remains highly challenging to introduce this motif, and new synthetic method has to be developed to extend the molecular diversity. So it is in this optic that we developed the synthesis of 2SF5 adenol by using commercially available boric acid with easily available SF5 alkyne under palladium catalysis. The reaction leads to the formation of 2SF5 adenol as a single regioisomer, as confirmed thanks to X-ray diffraction. The transformation work well in high yield with all the SF5 alkyne we tested, including differently substituted aromatic or heteroaromatic and aliphatic substrate. And by increasing the stereochondrons, we start observing some atropoisomerism, which show that the SF5 could act as a blocking group and generate atropostable molecules. We then perform the scale-up of the reaction up to 1.5 gram by a catalyst loading reduced to 0.5 mol%, which can be useful for an industrial application. Then we extend the scope of this transformation with several boric partners. We were happy to see that the reaction is not limited to boric acid, since boric ester or trifluoroborate salt gave a similar yield range. Then we demonstrate that that electron deficient or electron rich group at different position of the basing ring gave the desired product in moderate to good yield. The reaction was also compatible with heteroaromatic boric acid, such as thiophene, as well as ketone boric acid and activated imines. Since andenones are widely present in drug development and in nature, we oxidize the 2SF5 andenol under mild condition in high isolated yield. This gives us access to structure very close to drug candidates, which highlight the potential application of our method. We then finally evaluate the reactivity of these adenone in some functionalization. Strong nucleophile perform selectively 1,2 nucleophilic addition, whereas with softer nucleophile, we demonstrate that it was possible to realize diastereoselective 1,4 Michael addition, and leading to quantitative yield and a single diastereoisomer, even with bioactive compounds such as amoxapine. With this example, we show the versatility of this adenone and their easy functionalization even at late stage. So this is where the story ends. Thank you for listening, and don't hesitate to check the article we published in Angewandte with the front paper for more information.